In the last video in section 5.9, we talked about complex numbers and adding and subtracting. Now this particular lesson is going to talk about multiplication and division. So in order to multiply, I've got a couple of examples here on the board. First of all, example number 1, I have negative 7i to the second power. Well, if you're going to do this and do some multiplication, very simply, the second power means you multiply itself or times itself twice. Well, very simply, I have negative 7i times negative 7i. We all know negative 7 times negative 7 is 49. And then the I times I works just like any variable. You add the powers, that becomes I squared. However, in one of the prior videos, you learned a property of imaginary numbers that's very important. And we're going to use this a lot in this particular video. You learned that I squared is equal to the number negative 1. So therefore, anytime I have an I squared part, I need to substitute in the number negative 1, which equals then 49 times negative 1. And so my final answer is negative 49. That is what negative 7i to the second power is. And that's how you handle situations dealing with squares or cubes or anything like that. Now, example number 2. 4 plus 3i times negative 1 minus 2i. This looks very similar to something we did or have done in the past where you multiply two binomials together. These are two binomials. And you learned that in order to multiply two binomials, you have to use the word FOIL. And you do the same thing with imaginary or complex numbers. So I'm just going to write out F-O, actually I'm going to give myself a little bit more room, F-O-I and L, and I'm going to multiply the stuff together. The first terms are 4 times negative 1. The outsides are 4 times negative 2i. The insides are 3i times negative 1. And then the last terms are the two imaginary parts. That's 3i times negative 2i. Now, if I simplify this, 4 times negative 1 is negative 4. 4 times negative 2i is negative 8i. 3i times negative 1 is negative 3i. And then the last part, 3i times negative 2i, is negative 6i squared. Now, anytime you FOIL or multiply complex numbers, first of all, the O and the I work just like anything you've done in the past. They are like terms, so I need to put them together. So I'm going to bring the negative 4 down, and then negative 8i and minus 3i is negative 11i. However, from just the prior example right here, I have an I squared. I need to replace that with negative 1, so I have negative 6 times negative 1. Well, very simply, negative 6 times negative 1, I'm going to write the whole thing out. I get negative 4 minus 11i, and then this part in the circle becomes positive 6. And those two numbers are like terms, so I can add them together. Negative 4 plus 6 is positive 2 minus 11i. And that is your final answer to this particular problem. Don't forget, I squared is negative 1. You need to replace that. That will usually happen when you multiply two complex numbers together. And we must write our final answer in complex number form. The real part, the 2, is first, and the imaginary part, the negative 11i, is second. And that's multiplication. Now let's talk division. In order to do division, there's a word that you need to know. It's called conjugates. Two complex numbers are conjugates where the real parts are exactly the same, but the imaginary parts are opposites. So for instance, I made a chart, complex numbers. If you have the complex number negative 6i, all you do is change its sign to get its conjugate. So the conjugate of negative 6i would be positive 6i. The conjugate of 1 plus 7i, all you do is you change that symbol in front of the imaginary part to get its conjugate. So its conjugate would be 1 minus 7i. If you notice, the real parts stay the same. They do not change. And the last one, again, all I'm going to do is change its sign. Negative 8 minus 10i, its conjugate would be negative 8 plus 10i. The only thing that changes for the conjugate is the sign in front of the imaginary part. Now, let's use that knowledge to do some multiplication, or I'm sorry, do some division. First problem, 3 plus 7i divided by 8i. When you divide, the rule is to multiply the numerator, I'm going to abbreviate, and denominator by the conjugate. We just covered that word. This is where and how it's used. So what I'm going to do is I notice in the denominator it's 8i. So I'm going to times both the top and the bottom by negative 8i. Now if I do that, I'm going to put the top in parentheses and I'm going to distribute. So negative 8i times 3 would be negative 24i, and negative 8i times positive 7i would be negative 56i squared. In my denominator, negative 8i times positive 8i is negative 64i squared. Now I'm going to simplify those I squareds. I get negative 24i, and this part becomes, this part and this part right there become negative 1s. So if I put negative 1s in their place, very simply, negative 1 times 56 is plus 56, and in the denominator, this becomes negative 1 times negative 64, which is positive 64. Now I can break it apart. And I'm going to circle the real part first. Obviously, this part is the real part. So that's going to come first. I'm going to get 56 over 64, and then this minus sign, minus 24i over 64. Now, if I do some reducing, if you reduce these fractions, I believe 56 over 64 becomes 7/8 minus, and then 24 over 64 becomes 3/8 times I. And that is how you simplify this particular problem. And that's what you do when you multiply by the conjugate. Okay, the last example for division. 5 plus I divided by 2 minus 4i. As you just learned in the prior example, you can't have i's in the denominator, so in order to get rid of that, we need to multiply by its conjugate, which would be 2 plus 4i. And we're going to do that on the top and the bottom. Now what we have is a situation where you have to FOIL. We have to FOIL the top, and we need to FOIL the bottom. All right, so let's FOIL the top first. F-O-I-L, and then we'll put the two pieces together. If I FOIL the tops, I have the F is 5 times 2, the O 5 times 4i, the insides would be I times 2, and the last terms would be I times 4i. And if I simplify this, this becomes 10 plus 20i plus 2i plus 4i squared. And if you remember, I squared is the same as negative 1. And so I get 10 plus 20i plus 2i minus 4. 10 minus 4 is 6. And then these two become plus 22i. So that's going to become my numerator. Now let's FOIL the denominator. Oops, I'm going to space this out a little bit. F-O-I-L. If I FOIL the denominator, 2 times 2 is F. The outsides is 2 times 4i. The insides is negative 4i times 2. And the last terms is negative 4i times positive 4i. Well, this F becomes 4. The O becomes plus 8i. The inside becomes negative 8i. And the last terms become negative 16i squared. Now, the reason that you multiply by the conjugate is because you're going to notice that the insides and the outsides will always cancel out if you do it properly. So those two are gone. That will always happen. The I squared becomes negative 1, so I get 4, and then negative 16 times negative 1 is plus 16, which equals 20. And that's my denominator. So if I put the two pieces together, my numerator is 6 plus 22i, and my denominator is the number 20. Now I'm going to do a little erasing because I just got to simplify. The real part becomes 6 divided by 20, and the imaginary part becomes 22i divided by 20. And if I reduce those fractions, I believe I get 3/10 for the real part, plus, and then the imaginary part becomes 11/10 I. And people, that is how you solve these particular problems and how you use the conjugates in order to divide. We must always write our answer in complex number form, the real part first, the imaginary part second, and we cannot have any i's in the denominator. If you have further questions, please ask me during class.